let's take a look at the problem of the day. And the problem of the day says we're going to find the sum of the degrees in a convex octagon. Ooh, that's a mouthful. Convex octagon. Well, let's see what a convex octagon looks like first of all. So you say, oh, I've seen that shape before. Usually it's red. Usually has the word S-T-O-P in it. But that's what we're looking at here. This is a good old convex octagon, which basically means all our angles are on the inside there. If you'll take a look at those. And they could all be the same measure. They don't have to be. All right? Convex does not mean that. The word regular, however, if I said a regular octagon up here, we would make sure all of our sides and all of our angles were congruent to each other. So then you could say they have the same amount of degrees. However, no matter what the octagon looks like, whether it's perfectly regular or if it's got a little bit of a lilt here or there, a lift here, there, yawn, whatever, they're still the same amount of degrees. And that's because we're going to make triangles happen in this picture. So you say, Ernie, what's going to happen there? What are we going to do? Well, what we're going to do, let's take and see what happens when we pick a vertex here. Put a vertex right there. You see where we got it? Did everybody see where I put it? Right there. One vertex. There are 8 of them, by the way. We just pick one. You say, well, could you pick all of them? Well, if you did, you would have a big mess, all right? So for what we're going to do here, we're just going to pick one vertex. And what we're going to do, we are going to draw in diagonals. Right there's one of them, okay? And notice what that did. When it straightens out a little bit better, there we are, makes a nice triangle. You say, wow, that's interesting. Let's do it again. Go over to that point right there. There's another great triangle. So now we got 2 of them. We got some more space to work with. Let's go for it. All the way across the board. There we go. There's the 3rd triangle. Keep with me. Here comes number 4. Ooh, how about it? Number 5. Oh no, we got 2 on that one, didn't we? We got 2 for the price of 1 diagonal. 1, 2, 3, 4, 5, 6 triangles total in that picture. So I threw in 1, 2, 3, 4, 5 diagonals, but we get 6 triangles as a result. You say, well, what are we going to do with those 6 triangles? We're going to figure out how many degrees are in 6 triangles. Now that's how you break down a problem that looks rather intimidating from the beginning. So we took it, and by the way, if you start drawing it from all these, oh goodness, you're going to have so many triangles in there you won't know what to do. So we're going to take it very simply. We're going to pick up one vertex, draw 5 diagonals, all right? Now let's go to a little point here. N, we're going to say N, you know we love variables, we got to get some algebra in here or some stuff like that, right? So here we go, N is going to equal the number of sides. That seems easy enough. And there are 8 vertex points, there are 8 sides, there are 8 angles. 8, 8, 8, 8, that's an octagon. That's why we call it an octagon. So there are 8 sides altogether. So in this case, our value is 8. So what we're going to do, we're going to take and figure out, now what do we do? My friends, in each of these triangles, how many degrees? Good old, what I call the blockbuster theorem of all geometry. Really, it's a big one. It's a big one because without it, you can't do anything else in it. There are 180 degrees in each of these triangles going here. Oh my goodness, is that not great or what? So 180, I counted 6 of them. This is sounding pretty easy, isn't it? So we're going to take 6 triangles and we are going to multiply those times 180 degrees, not 108 or 18, but let's go 180 degrees per triangle. And when we do that, pretty straightforward and simple. Let's let the calculator do it for us, but I'm going to tell you, I think it's going to be 1,080. Let's check and see if I get there. Let's see if I can get there. Let's see if I can get there to the calculator. Here we go. 180. And we're going to multiply it times 6. And my friends, that's going to give us 1,080 degrees. 1,080 degrees. Now that is if we picked up this angle plus this angle, and we get this angle. See, we got a lot of angles that are formed by 2 adjacent angles in there. Now I'm not saying, I kind of made a mark there because I just don't want to have too many different marks going on. I'm not saying that those are going to be all congruent length, but I'm going to just simply mark, those are our interior angles that we're adding up here. So these one, let's see how many are there all together. And then there, whew, that one's got a lot of them connecting. If it were regular, they would be all the same size. So we may pretend. How about it? But anyway, 1, 2, 3, 4, 5, 6, 7, 8. There you go. Now we're working. Now we're cooking. So the question here asks what was the sum of the degrees of convex octagon. Some people get a little nervous because that's a lot of degrees. But that's because if you look at these, they spread out more and more. The thing is, there's a formula. You know, there always seems to be a formula. Not always, but in this case there really is. We're going to take the number of triangles that are formed, which, by the way, we started out with 8. We ended up with 6. And no matter what you do, if you put a vertex in a polygon of any kind, you start slicing off triangles, there's always going to be 2 less triangles than number of sides. So we're going to pick up this n minus 2 business. That's the number of triangles times 180. And folks, that's the total sum of degrees formula. One of those things on the state math geometry papers, and use that formula is there for you to use. You just got to know what to do with it, what n stands for and what it's all about. That's where it comes from, simply breaking down in a convex polygon of any kind, in this case it's an octagon, into your little bitty fun loving triangles, which you know how to do, 180 degrees in each. And that's an easy way to get through the problem of the day.